Hello, my name is Per Dimitri. I'm from the Knowit office in Oslo, Norway. For this year's SAS Hackathon case, we at Knowit have looked into the challenge of diabetes risk prediction. For a month now, our team has collaborated with the company Health Integrator. Health Integrator focuses on utilizing digital means in order to prevent lifestyle-related illnesses such as diabetes. Now, why would we want to do diabetes risk prediction? Well, individuals at high risk of type 2 diabetes may reduce their diabetes risk by about 30 to 60% through intensive lifestyle intervention. Well, to do this lifestyle intervention, we would naturally have to identify these individuals of high risk. In order to identify them, we need to do diabetes risk prediction. So that's the why. But how would we go about doing diabetes risk prediction? Well, this story goes all the way back to 1987. In 1987, great things happened in Finland. Nokia made its first phone. But more relevant to our endeavor is that the Knowrisc study began, the Finnish diabetes risk score. This was developed by these two individuals and is a practical tool to predict type 2 diabetes risk. The Knowrisc is a simple, fast, inexpensive, non-invasive, and reliable tool to identify individuals at high risk for type 2 diabetes. It is thus of no coincidence that it is often referred to as the gold standard of diabetes risk prediction in scientific papers. Now, the Knowrisc was developed all the way back in 1987, continued for about 10 years. Now we're in 2022. The data from Health Integrator is from 2020. We're not in Finland, we're in Stockholm, Sweden, and all of this makes us wonder, what is the validity of Knowrisc in our case? Let's look at this study from Norway, looking at the validity of the Knowrisc as a prediction tool. Let's look specifically at the conclusions and zoom in on the conclusions. And here we can see that to identify 3/4 of those developing diabetes, we have to label 1/3 of the entire adult population as having high risk for diabetes. This means that we run the risk of a lot of false positives. Furthermore, we tried the Knowrisc model on the Stockholm data and compared it to the result from the original study. And here you see the Knowrisc model on the Finnish data, which gave an optimal score of 22%, and the Knowrisc model on the Stockholm data, which gave a score of 11%. What this told us was that there probably is some room for improvement, meaning that we could make a model that was more tailored for the Stockholm case. Making a tailored model is exactly what we did. We took the data provided by Health Integrator of the Stockholm region and fed it into the Knowrisc model. We obtained a score, and this score was then passed on further to a state-of-the-art machine learning model in order to be improved. In addition to stacking the Knowrisc model with a more advanced model, we added socioeconomic variables in order to improve the score. So by stacking the Knowrisc model with a machine learning model and adding several new variables of the socioeconomic type, we managed to improve the score significantly from 11%, which is the original Knowrisc model on the Stockholm data, to 20%, which is this Knowrisc model's score. With this improved Knowrisc model, we can more reliably say something about a person's risk of developing diabetes, particularly if that person lives in the Stockholm region. The Knowrisc model outputs a score. This score is easy to interpret. If it's above 19, the person has a high risk for developing diabetes. The Knowrisc model can be used in the same manner as the Knowrisc model, meaning that it has all the same inputs, weight, height, daily food consumption, and so on. The only additional parameter that the Knowrisc model needs, that the Knowrisc model doesn't have, is a postal code. This is in order to obtain the relevant socioeconomic data. To create our model and do all the necessary feature engineering of the data in beforehand, we set up various Jupyter notebooks and wrote our code in Python. This was easily done within the SAS Viya cloud environment. Here you can see how we do some analysis on how different features contribute to the risk of diabetes. After we have trained our model, we could set up functions such as this one, where we look at the path of improvement for a specific patient, or we look at what contributed to the score that this patient obtained. Using SAS Viya Visual Analytics, we created a dashboard for Health Integrator to use. They can, for example, use it to assess demographical risk factors, or something simple like looking how many users they have in a given area. They can also use the dashboard to assess the distribution of the Knowrisc score and see how well a given decision boundary fits with reality. They can use it to look at other distributions such as the BMI distribution, age distribution, sorted by whether we're looking at diabetes cases or no diabetes cases, correlations, and probably most interesting, the Knowrisc calculator. This is analogous to the Knowrisc calculator. You set an age, you set gender, weight, height, and so on, and a location, and then you get a Knowrisc score. And then you can evaluate what contributed to that Knowrisc score.